May, you're a lawyer and environmental policy expert who recently served as a Deputy Assistant Administrator for Water at the US Environmental Protection Agency. Few people have seen what you've seen, what it really takes to regulate something as complex and as politically charged as PFAS. So I'm really looking forward to talking to you about that today, about what it takes to set regulations, why sometimes we can't set them, and what will it take for us to get this right. So
Yeah.
thank you so much for joining us today and for agreeing to be part of this enlightening discussion for anyone who's listening.
Yeah. Well, I'm happy to be here and happy to chat with you.
Thanks. Let's get straight into it, starting with the role of the regulation and how important they are. You worked on the inside of one of the most important regulatory bodies in the world. Why do you believe regulation is essential to addressing challenges like the PFAS contamination? And what does regulation do that, let's say, voluntary action can't do?
Um, yeah, it's a big question. It's important. I mean, there is a role for voluntary action, but I guess that underscore that's the word voluntary. And
Yeah.
that's the big difference between that and regulations. Regulations are, requirements that companies or utilities or whoever it is, the regulated industry have to do. And so it really I think regulations are really important, especially for setting a floor. Like we are
Mm.
not going to let ourselves get below this certain amount of whatever it is, contamination or something. Voluntary action is great, especially when you're trying to go above and beyond.
Yeah.
That's where you're going to see innovation and some really great things happening. But not everybody's going to do that. Not everybody's going to want to get out ahead and take these big, huge new steps. And so we have to make sure that there's at least that floor there for and
Mm.
that's what regulation does.
So basically, set some basic requirements, or at least there's something that sort of addresses the critical challenges we face, sets a baseline of at least some action take place.
Exactly.
Yeah. No, I like that. Thank you. So the EPA's, if I'm not wrong here, and you can correct me, so the EPA's proposed drinking water standards were focusing on six PFAS compounds out of thousands. Can you walk us through how the EPA decided which compounds to regulate first, and how to even go about setting these specific limits that were set?
Yeah. So actually, EPA didn't just propose. When I was at the EPA, we actually finalized those regulations, those
Yeah.
drinking water. So they're out there. They're now the requirements, and it was six of the tens of thousands of PFAS is there. The statute under which drinking water is regulated in the United States requires EPA to make some different findings. They have to
Mhm.
determine if they're going to regulate a contaminant that first that it has the potential to harm human health. Second, that it occurs in drinking water at a level that may cause harm to human health. And then there's like this final, it's a little wishy washy, but the administrator, the head of the EPA, has to determine that setting this regulation would create a meaningful opportunity
Mhm.
to improve improve health by setting
Mhm.
this regulation. So EPA had to do those first two prongs first to decide to set the regulation. So it has to look at the science out there on what we know about the impact that the chemical
Mhm.
has on human health. And when we're looking at the PFAS, we have a lot of information about some of them, a couple of them. We have some good information on some more, and then there's a lot we don't know about. And so
Yeah.
that's why EPA focused on the six that they did, is because they knew that they had a lot of science
Mhm.
around those six, and that a lot of the monitoring that we've done has shown that they're showing up in drinking water. And then, a lot of the regulations all about like now where do we set the level? How are we going to require monitoring for it? Things like that. All of that goes into that decision. But that's how they picked the six that they did.
All right. So from what it sounds like, it's a prevalence, how often they're found, they need to have sound scientific backed data on them as well. And then
Yeah.
I guess so the limits are then set arbitrarily in a way then, because I remember they were like different values, right? For the long chain and medium chain. So I guess that I would assume the analysis and what you can even measure also plays a role in that, I would assume,
Yeah.
to set these numbers, right?
Yeah, it's definitely not arbitrary. That is you use a very legal term there. Federal agencies can't do anything arbitrarily.
Yeah.
So what the Safe Drinking Water Act requires is first the EPA to come up with a number that they call that's called the maximum contaminant level goal.
Mhm. Mhm.
This is the number below at which there's no harm to human health.
I see. It's the
This
peanut
is the
values, so to speak.
this is the number, yes.
Yeah.
Here
Mhm.
and below, we won't see any impact to human health, harm to human health. And then EPA then has to determine what's called the MCL, the maximum contaminant
Mhm.
level, which is then the number that gets as close as possible to that
Mhm.
goal, but that is feasible. So it may
I
be
see.
that the technologies that exist today can't get us all the way to the MCLG, or there's no way to
Mhm.
test all the way there, or whatever it is.
I
So
see.
there's a feasibility determination where EPA says, okay, well, we can get this close to it or whatever. And so that's how EPA came up with the numbers they did, was first figure out that goal number and then get as close as they could to that goal.
I see. Okay, that makes a lot of sense. Thanks for walking us through that. And I'm happy
Yeah.
that it's not arbitrary. It's a question that's asked all the time. How did we come up with those numbers? So it's always science backed, and there's a
Absolutely.
logic behind that, obviously. As a curiosity for me, because as you said as well, there's so many of these PFAS compounds, thousands out there. Do you feel following the same process as was done for these six compounds? If you were to expand that to hundreds more, we could follow a same process, and maybe for the next phase it could be more compounds and faster? Or do you feel like we need to wait and collect more and more data for all of these compounds, and that could just take longer? Or do you have hope it could be faster for the next set of regulations on PFAS?
Yeah, I mean, that's something that even when I wasn't working at EPA, so before I was working there, I worked in environmental advocacy on environmental
Yeah.
health, trying to push EPA to
Yeah.
do stronger regulations. And it is difficult because of the way that the Safe Drinking Water Act is written. Um,
Mhm.
that it's hard to do like as a whole class of chemicals altogether. Now, are there ways that EPA could maybe now knowing what they know about like these six, like build out from there without needing to have like that much
Uh-huh.
information? Maybe. It's hard to say because, there's also a lot of litigation that gets involved.
Yeah.
Folks who don't want to see all these regulations. But I would say one of the good things is that, at least kind of good, is that the technologies that you would use to get rid of those 6 PFASs
Yeah.
will get rid of a lot of the other ones too, right?
Yeah.
So, I think, again, technology and innovation in these areas
Mhm.
around remediation and destruction of PFAS are
Yeah.
really because that's probably what's gonna move faster than doing enough studies to get
Yeah.
to the next PFAS.
Yeah. That's actually a great insights, because if you can treat them the same way and analyze in the same way, you could start setting similar standards to others as well. And I think this could apply quite well for the long and medium chain PFAS compounds, and where maybe it might be a bit of a trickier situation might be these new compounds called ultra short chains that are popping up more and more today, like TFA, PFPRA, where analysis is challenging, detection limits vary quite significantly, and the existing treatments that would apply for long chain and medium chain are not the right solutions, says it seems, for these short chain compounds. So, how do you think we can go around seeing regulations for them, or would we anytime soon, considering the complexity that these compounds pose? But at the same time, they're popping up everywhere right now. So, health concern, or how would you go around this big new hot topic on PFAS short
Yeah,
chains?
I mean, I think it's hard. Emerging contaminants is a
Mm.
complicated way because again, how our how our laws are structured, where, EPA has to make certain showings before they can set these regulations.
Yeah.
And so, if we've got these brand new chemicals that we don't have many studies on their impacts on human health, if we're not even monitoring for them, and it's not just any kind of monitoring program. EPA has its own process for identifying what contaminants it will monitor for. So that's a whole process to like decide
Mhm.
which contaminants to monitor for. And they do it for like years, right? And then they collect that
Mhm.
data. And then they have to decide, like, is it showing up enough? So there is
Yeah.
a lot of steps. The Safe Drinking Water Act is not a fast moving nor nimble statute. And that's why it was such a big deal that we even got
Yeah.
that first PFAS drinking water standard that we did, it doesn't move that quickly. So again, this is where the voluntary and the innovation and stuff, that's where it's going to have to pick up while we're
Yeah.
waiting for other things to catch up to the statutory standards.
I see. So I guess if you can show and demonstrate you can analyze these to the new levels, if you can destroy or treat them down to a certain limit, that should enable the regulatory side to also move a bit more because I guess we're still missing a lot of data on short chains, right? How much
Yeah,
can we treat them to? Can we even analyze them to the right detection limits? A lot of unknowns today, right? So I think,
there's a lot.
I guess a hand in hand work needs to happen. Regulation needs help from, I guess, industry, other stakeholders for this information. So, yeah, I guess that time will tell how fast we could all move on them. And I'm definitely very curious to watch that. And I guess out of a curiosity perspective as well. So, when a regulation is set up on this sort of massive scale, can you walk us through like what does it actually take to set PFAS regulations? And what kind of stakeholders are involved? Like, are they all like industrial players? Are they a medical community? I guess regulators. So, could you walk us through who would sit on a table like that to set up a regulation, and what kind of data is needed? And if there are any hurdles that you've encountered in this process as well.
Yeah, I mean, there are a lot of different stakeholders who provide input on it. When EPA develops, say, a drinking water standard, for the most part, what happens is EPA collects a lot of the information, gets all the science they need. Um, they may have some, meetings with different stakeholder groups, and then EPA will go and write a proposal itself. It'll put
Mhm.
the proposal out for the public, and then open it up for people to comment and say, we think this number is too high. We think this number is too low. You didn't consider this and stuff. And so there could be hundreds, thousands, millions, depending on the regulation,
Mhm.
comments that EPA will get and have to respond to
Uh-huh.
and consider before they write their final regulation. So sometimes the final might look different from the proposed because somebody might submit something like, oh, yeah, we didn't think about that. Great point. Let's incorporate that into the new rule.
Mhm.
Um, but the groups that are involved, I mean, they would run the entire spectrum. You will have your, NGOs, your human health, public health, folks who'll be pushing and giving new information. You'll have universities that are doing research that could provide more information. You'll have the industries,
Mhm.
and in this case, the industries would be your drinking water utilities, right?
Yeah.
The oftentimes municipal or whatever organization is that delivers water to your house. So they'll have
Mhm.
onions because they're the ones who are going to have to put in the technology, right, to clean
Yeah.
it up and do the sampling. You'll have the industry also, like the PFAS manufacturers. They'll probably submit comments, and everybody has
Mhm.
some some role to play in
Yeah.
providing that information to EPA. But the data around how much PFAS there is occurring in the water, that's the drinking water utilities. They're the ones who do the
Mhm.
sampling, and they do the testing and submit that information to EPA. Then EPA collects it all and starts looking at that to determine, what's popping up a lot and what's not really showing up that much. And then they'll
Mhm.
start making some decisions based on that.
Yeah. And this sounds like a long process. So how long was this, if I may ask?
Um, from Actually, I think PFAS went pretty quickly given how long usually things take. So, if you want to talk from the very beginning, EPA first has to do a regulation to identify what contaminants to do the sampling for.
Mm-hmm.
That takes a couple of years. And
Mm-hmm.
then once that rule is finished, then the drinking water utilities have 3 years or so to do all that sampling. And then EPA collects all those samples and then collects all that data. And then at the same time, they'll also start collecting the science on the harm of the
Mm-hmm.
chemical. And then that could take another, couple of years for them to then draft the proposed rule. Then they'll put it out for comment for 30, 60, 90 days,
Mm-hmm.
get all the comments back, read all the comments, figure out what they need to do. It could be another 6 months, 12 months,
Mm-hmm.
18 months, 2 years to do their final. So you're talking, it could be 8, 9 years from
Yeah.
when EPA start thinking about whether they need to worry about a chemical to
Yeah.
when you might see the final one.
All right.
It's not quick, it's not nimble.
Yeah. But at least you could sort of say when something is set, it was properly reviewed with a lot of information, a lot of information collected from diverse stakeholders. So, yeah, so I guess there's a lot of sort of trust in this process from the market, then from the stakeholder sense. That's, I guess, a good point as well. Um,
Yeah.
and I'm also mindful, like in this context you were speaking, we're talking about drinking water quite a lot. And I feel that we
Yes.
do focus quite heavily in Europe and in the US as well on the drinking water quality. But obviously, a huge piece of the puzzle when it comes to contamination happens at the point source, like the industrial diffuse source, like the
Yeah.
industrial discharge of the water. How would the process of setting, like, let's say, discharge limits
Yeah.
on industrial discharge of
Yep.
waste compared to that of setting drinking water standards? And what would you perceive would be the biggest blockers of even tackling that at the
Uh-huh.
industrial state?
Well, so I've been talking about the Safe Drinking Water Act. So
Yeah.
now with this question, I'm going to pivot to the other water statute
Yeah.
that we have in the US. It's the Clean Water Act. And under the clean water, so I kind of think of the difference as like all the lakes and rivers and streams, that's the Clean Water Act, all your surface water. And then once
Mhm.
it goes into a drinking water system, that becomes the Safe Drinking Water Act. That's kind of where the two
Okay.
statutes kind of
Yeah.
diverge. So the Clean Water Act has actually um, a program that's called ELGs, Effluent Limitation Guidelines. And so those are the ones where EPA will put limits on dischargers who are
Uh-huh.
discharging into a body of water.
Mhm.
Um, and that one is actually very different from how drinking water is regulated because it's very technology driven. And so what they do is they figure out they have things like what's the best available technology, what's the best available practical,
Mhm.
technology, and then they decide like, okay, this is the best available technology and it can cut things down to
Uh-huh.
whatever parts per billion, parts per trillion, this percentage. And then they set that as the limit.
Mhm.
And so then companies just have to meet that limit. And so they could use that technology that EPA relied on, or they could use something else. Like maybe they find
Mhm.
some new technology that they, isn't, prevalent out there, but actually can do it more cheaply or more
Mhm.
quickly or more effectively. They could actually, and it works better in their process. They could actually put that in there. So the effluent limitation guidelines are really what I think are more technology driving, innovation driving kind
Uh-huh.
of process, which I think is
Mhm.
really interesting and great. They're also resource intense as far as developing them.
Yeah.
And so, the way that EPA thinks about them right now is by different sectors. So they're looking at first, they'll look at PFAS manufacturers and then do all the calculations and figure out what kinds of limitations could be there. Then they would pivot to a different sector, and it might be,
Mhm.
the finishing or processing or whatever, right? They do it like by different industrial sectors, which I think is part of what would take longer. Like
Yeah.
instead of just all industrial discharges, they don't do it that
Yeah.
way, right? They break them down. But I think
Mhm.
that, when you go up and um, adjust the source, that's going to be a much more effective and efficient way
Yeah.
of dealing with contamination than going downstream and making the water utilities put
Yeah.
in all this ACK or RO or whatever to
Yeah.
address it. I'm hoping that this EPA will try to get some ELGs out there too.
Mhm. I mean, so from what it sounds like, and correct me if I'm wrong. So if you have BAT set up for that, then you as a company who has to comply with these limits could use that or something similar that has the same outcome. So how would a BAT like this be set as well? I guess that has its own regulatory process that needs to be followed. I guess like independent piloting and claim making, or how is a BAT set and how long can that take?
Oh, PAT. Well, so I did not work that much. I worked a lot on the drinking water standard, as you can tell. I
Yeah.
didn't spend as much time on this part of the Clean Water Act. So I don't know the ins and outs, but
Mhm.
it is, EPA has a team of folks who do know this well, and they will
Yeah.
go first do a survey, I think, of all the
I
technology
see.
that are available, and then they figure out like which ones are um, available
Hmm.
versus our niche or still coming up, right? But it has to
Yeah.
be something that is widely available so that
Yeah.
anybody can get on. So there's a lot of things, but I think it is important to make sure that EPA knows,
Yeah.
to whoever is working on this, that that technology exists to
Yeah.
get on their radar first as like, we should be the standard. you
Yeah.
know, and hopefully again, as companies innovate more and develop a better and more effective and more efficient processes for treating these, then that can actually EPA could ratchet down
Yeah,
that level
they
of
can trickle down
right.
into a stricter BAT that you could follow. Yeah, absolutely. I
Yeah.
appreciate you walking me through that. I know it's not in your direct purview, but I was just curious if you could shed some
Yeah,
light on the BAT process as well. It's super fascinating for technology providers to know what's happening behind the scenes.
absolutely.
So yeah, coming from there and um, also obviously reflecting on some of the recent news we've heard from EPA around some of the rollbacks and policy changes. I guess you know pretty well how fragile the regulatory momentum can be. There are recent reports that the EPA has delayed or even walked back on some of these elements of the PFAS roadmap that we were talking about. Can you walk us through what these recent rollbacks could look like or do look like? And what's your personal reaction to them after working so hard on them?
Well, some of the stuff is things that we've seen them announce, but we haven't actually seen them do the
Yeah,
administrative step, right? So, and then just as there's a long process to write a regulation, there
yeah.
may be a long process to amend it or change it in some
Hmm.
way. And at least in the Safe Drinking Water Act, there's a very specific provision in that statute that says that any if you finalize a regulation, any new regulation you do related to that one, it can't be weaker than the one you already have.
Uh-huh.
We call it
Okay.
anti-backslide. It's a great provision in the Safe Drinking Water Act. It's important, right? You want to always be
Yeah.
protecting more and more. Um, and so, you know, we are hearing things, but it's still early on that EPA hasn't had enough time to actually go through the process to see what it is
Hmm.
they're actually going to do with some of those rules that we did. So it's a little bit of wait and see.
Hmm.
Obviously, I'm hoping that they continue to be protective and continue to find ways to reduce human health exposure to PFAS. I think it's pretty clear, the science is
Yeah.
clear that
Yeah.
they're harmful to
Yeah.
us. And we are all being constantly exposed to them. So, for an agency that's mission is meant to protect human health, one would hope that they will continue to work to protect human health.
Yeah. So there could still be a lightning of hope at the end of this process where they could stay, or the rollbacks might not take shape. Is that something we can say, or that's, let's say, a hope today, at least?
We can hope. Well, we'll have to see. And
Yeah.
in the U.S., we have the court system too,
Yeah.
right? So if they take steps that actually are not part of what the Safe Drinking Water Act allows, I think there are a lot of groups who are watching what they're doing. And if they're unlawful, then you can be sure that there will be groups who will bring a case against EPA
Yeah.
um, to prevent them from doing it. So
Yeah.
again, long process.
Yeah. No, no, yeah, of course. I keep my fingers crossed here, as I'm sure everyone else is in the EPA is also doing that. Looking forward a little bit now. The next few years are going to be crucial. Many scientists are now describing PFAS as a planetary boundary threat. If you could shape the PFAS policy for the next decade, um, what are the top priorities that you would push for? And where do we have to go from here?
If I was queen of the universe,
If you could
and I had
paint an ideal policy that you could just push for, what would that look like?
the deal policy.
Mhm.
Well, I think uh, it is important. I think, going to the source is an important part.
Mhm.
So I think that part of it is going to be, reducing. I'm the queen of the universe, eliminating all
Yeah.
contamination coming um, out of the production. But I also think, it'd be really interesting to see, more requirements before you're even allowed to make or
Mhm.
sell, right? These
Mhm.
chemicals, products with these chemicals to get some kind of approval,
Mhm.
you have to show that, you're not going to harm human health in doing it. And since I'm still queen of the universe, I think um, what we also need is some real, and I don't think this is policy necessarily, but I think destruction technology is going to be really important because right now, a lot of the things that we're doing is capturing the PFAS,
Mhm.
taking it out of the drinking water.
Yeah.
But then we just have now a different contaminated membrane or, GAC or whatever it is. And so we haven't actually addressed this problem of like
Mhm.
PFAS existing. And so I'd like to see a lot more work and you know stuff around destroying this bond
Mhm.
instead of just capturing it. Those
Yeah.
are some you know big big pieces.
Yeah, I love everything you said. I really hope we can transform tomorrow as a queen of policies and regulations from tomorrow. I think the world will really use your optimism and drive on them. So I keep my fingers crossed also for that. Um, Final question. In
Yep.
one sentence, what keeps you hopeful about the future of our water?
Hopeful. It's knowing that people are aware and care about the quality of the water on this
Mhm.
planet and realizing what a precious resource it is.
Mhm.
It gives me a lot of hope that going forward, we're going to do as much as we can to protect it.
Mhm. Love the answer. Couldn't agree more with that. It's also what keeps me hopeful as well as someone trying to work on
Good.
this topic. So thank you for sharing that. It was lovely speaking to you, May. Thank you so much for your precious time and sharing your insights. I love every minute of it, and I'm pretty sure anyone listening to this will find this super insightful and hopeful. Better things are coming when it comes to regulations. So thank you
Yeah.
for your precious time. I really appreciate it.
Well, thank you. And thank you for all the work that you're doing on this. It's really important.